right? So how did I erase that over there? Crap. If we're given a 0, ladies and gentlemen, if we're given a 0, that means that factor that this is related to, right? Remember, set this equal to 0, so the factor is 2x plus 1. Does everybody follow me how I got that? I just set it equal. I just solved it, basically. Multiplied 2 on both sides, added the 1. Right? 2x plus 1 is 0, so it's really just 2x plus 1. So if this is a 0 of that polynomial, that tells me that this factor evenly divides into that. Correct? And we can verify our result by using long division or synthetic division. However, I'm a simple man. I would prefer to use synthetic division as long as I can, because this factor is linear, so we can use synthetic division, right? Or we have the 0, so we can use synthetic division, because we only really have to use long division when our factor is squared or so forth. So let me kind of go back to this reality. 6 over 3 equals 2. If this 0 evenly divides into this, which we know, so 3 evenly divides into 6, that's a factor. The quotient is also a factor. So what's important about that is whenever I divide this into it, whatever my answer is also going to be a factor. So let's go ahead and set up synthetic division, because that will be the easiest. Actually, I apologize. Let's do the rational 0 test first. The rational 0 test, again, tells us to find all the factors of our constant over all the factors of our leading coefficient. So we're going to do plus or minus all the factors of 15. So all the numbers that divide evenly into 15. 15, 5, 3, 1, all over plus or minus all the factors of 4. 4, 2, 1. Everybody follows? Now I can write out every single combination. Okay? Now for this video, I'll write out every single combination. But just moving forward, I'm OK with you guys just I'll tell you when a lot of times you can just write them out and only break them apart as you need. So my final combination is going to be plus or minus 15 over 4, plus or minus 15 over 2, comma, plus or minus 15 over 1, comma, plus or minus 5 over 4, comma, plus or minus 5 over 2, comma, plus or minus 5 over 1. See how this is giving me every single possible real 0, comma, plus or minus 3 over 4, comma, plus or minus 3 over 2, comma, plus or minus 3 over 1. And then I'm running off the board. So we'll do plus or minus 1 over 4, comma, plus or minus 1 over 2, comma, plus or minus 1. If there is a real rational 0, which there is one already, negative 1/2, which is represented right there. If there is all real rational zeros, it's going to be on this list. But just remember, this is not telling you all the zeros, because how many total zeros do we have? 3, right? And remember, there's other numbers than rational numbers. You have irrational numbers, like the square root of 2, or pi. Pi is not going to be a 0, but like square root of 2. And then also you have imaginary and complex numbers, right? Taking the square roots of negative numbers. Those are going to come into play as well today. So now let's go into synthetic division. So we take our coefficients, make sure they're in descending order, and make sure we have every single term. I'm going to do synthetic division a little bit quicker than last time. Is that OK? Although I have a couple people that weren't here. So bring down the 4. 4 times negative 1/2 is a negative 2. 16 plus negative 2 is positive 14. 14 times negative 2 is a negative 7. Negative 23 plus negative 7 is a negative 30. Negative 30 times negative 12, negative 1/2 is going to be a positive 15, 0. So remember, this answer is also a factor, right? But remember, the hard thing about, sometimes confusing thing about this is we need to understand what this is. Remainder, constant, linear, quadratic. So we can write this as 4x squared plus 14x minus 30. This is my other factor. This factor times this, which is the factor, let's write the factor above, 2x minus 1 plus 1. This times this gives you that. 6 over 3 equals 2. 6 divided by 3 gives you 2. 2 times 3 gives you 6. This divides into this, gives you that. This times this gives you that, right? I'm just comparing it with polynomials compared to with numbers. So what's important, though, if we have two factors and we want to find the zeros, what do we set our factors equal to? 0. So I have 4x squared plus 14x minus 30 equals, times 2x plus 1 equals 0. Now we just apply the zero product property. So I set 4x squared plus 14x minus 30 equals 0, and 2x plus 1 equals 0. Well, we already know what that 0 is. That 0 is x equals negative 1/2. That one's easy. But crap, what do we do here? This is a quadratic. We want to look to factoring. If it's not factorable, you'd want to use the quadratic formula, right? So first of all, here I see that I can factor out a 2. So I factor out my GCF of 2 plus 7x minus 15. Divide that 2 on both sides. And now I basically want to see, I'm sorry. Yeah, there we go. Factor out the 2, and then I divide it out on both sides. So now basically I have this. I need to see if I can factor it. So my first number has to be x, 2x, and 2x. And I say, all right, what two numbers need to multiply to give me negative 15? But then and then also include or is going to add to give me 7. And I did the problem over there, which I erased it. So let's see. To multiply to give me negative 15, one has to be negative, one has to be positive. OK? So since the middle term has to be positive, that means my larger of my products has to be positive. So I'm thinking 15 would be too big. 15 and 1 would not give me a difference of 7. But 5 and 3 might. And if I did the larger product, 5, 2x times 5 would give me 10x. And then I'd have to do a minus 3 here. And that would give me 7x if you combine the middle terms. So therefore, then I do zero product property again. And I have x equals 3/2 and x equals negative 5. How many zeros do I have? 1, 2, 3. How many zeros am I supposed to have? 3. Are these zeros all real? And are they all rational? Are they all in this list? Do you guys see 3/2 in here? Yep. Do you guys see a negative 5? Yep, negative 5 over 1. And we already knew negative 1/2. So there we go. Done. Kind of cool, right?